So our next speaker is Dr. Dori Peleg, and Dori is Sightful's Senior Director of Algorithms. He has a PhD in electrical engineering from the Technion, and actually we were together in the Technion like a few years ago. Dori has led the AI and algorithms teams for 15 years in companies such as Cortica, Given Imaging, Medtronic, and now in Sightful. At Medtronic, he led the AI for the gastrointestinal division. Dori will speak about what they are doing in Sightful and how to make a useful AI product in the balance of artificial intelligence, hardware, and user experience.
Thank you. Thank you very much for inviting me, and thank you all for staying. And as greater people than I have said, now for something completely different. Okay? So today I'll talk really about what we do at Sightful, and for that I'd like to tell you about our value proposition, which is productivity and privacy. So up until now, there has always been a trade-off between productivity and mobility. So when you're at the office, you have 2, maybe 3 screens, if you like a lot of screen space, and then you were most productive. But what happens when you're in between the office or in your home? So you take your laptop and you work on it, and you have like a 13 to 17-inch laptop, depending how much you're willing to carry and how much weight. And you're most mobile with your phone, you put it in your pocket, and this was a trade-off because there were physical constraints. But we would like to break that. So how do we get here? We want to be actually even more productive than at your office and be as mobile as your laptop. So this is it. Using augmented reality, we can actually project all the screen space you want on your glasses, and you can have the mobility and productivity together. It's not a trade-off anymore. And this is the world's first AR laptop, and this is our product. So what you see here is a laptop with no physical screen. There is a physical keyboard, which you touch. It's very important to have that tactile touch in order to be productive and type efficiently. But all the content is now in your AR glasses. And how does this look like? And this is, I know you may think this is like a commercial slide, but this is really how it looks like when you try it out. So that's the end to Alt tab or Option tab, depending on your OS. You see everything in parallel. You can work together more effectively, much faster. If you imagine all your documents, your Slack, your Gmail, your video call all together, seeing it all together, it's really an amazing experience. And it doesn't matter where you are, whether you're at home, at the office, hotel, on your car, plane, train, whatever. You can have this amazing, like here in NASA, everywhere, okay? Even if you don't have room for your legs. And for example, video conferencing. So typically, if you want to, God forbid, present something, then you lose all information of all the people that you're talking to. You can do either or. So here you can see them all together, and you can present and see who you're talking to as well. And really, this is extremely comfortable, and what's the beauty of it is also privacy. So you have this like 100-inch canvas, but it's on a few square centimeters on your glasses. So you have a complete privacy, as opposed to the most expensive laptops there on the market. If you're in open space, somebody walks behind you, they can see what you're working on. If you're on a train, somebody sits beside you, you have no privacy, but here you have built-in privacy as well. We've also won several awards. You can take a look at them, and we're very proud of our product. And today I'll talk about how to develop for such a product, because it's a pretty different use case than most of the things you've seen here today. And I like to be a bit philosophical for a moment, okay? In the parallel of the oak and the reed, so there is a big storm, and the mighty oak breaks under the wind, while the reed is nimble and bends and survives it. So when you're in the startup world, there are many storms. If you're developing a complete new product, there are many storms. If you're in Israel, there's many storms, and especially nowadays. Okay, so you're going to weather some storms. And so my philosophy is to be the read, and I'll show you how we did that in our development. So as algorithm engineers, we love complicated solutions. That's the fun, okay? Never mind the problems. The complicated solutions are great. But your users don't really care how you solve this. And algorithm engineers have a tendency to, if they have a big challenge, okay, let's put out the big guns, amazing models, and try to solve it. But I say that maybe you should think of also incorporating hardware solutions and UX solutions, and in this Venn diagram, work it right smack in the middle. And in the world of AR, you have to treat user testing as a loss function. The difference between a successful AR company and an unsuccessful company is how obsessed they are with their users and getting their feedback. It's very, very delicate, that experience that you want to have. And you can easily have a very shiny product, but nobody will want to use it. So one approach, how do you do this? One approach is to hire the world-class experts of UX in AR, and they develop product documents, lengthy product documents with smart KPIs before you start, and then you go ahead. But for me, it's like an analogy of trying to drive from your home to the office based on memory. I've done it a million times before, but the fact is there are too many unknowns you'll encounter, and 9 times out of 10 from my experience, the problem you're trying to solve in the beginning won't be the problem that you'll actually need to solve in the end. So to make a successful AR product, you must be first obsessed with collecting feedback from users and optimizing for it. And I suggest to start with very high-level requirements, not even smart, and get user or product feedback immediately, and iterate. Quickly plan, develop, test, deploy in very, very short cycles, as opposed to going to some theoretic KPIs. So I'm going to show you the first use case of this, and it's called keyword tracking. And it's going to be funny. So if you have a laptop and you want someone else to share what you're seeing, then just slide it over and turn the laptop. Okay? But this is different here. So in the world of AR, the algorithm that you use here is SLAM, so it's simultaneously mapping and localization it. So this means that you're anchoring the visual content to the place you're working at, okay, to the room, okay? So let's see what happens when you do that. So this is a person using just one screen, they're the modest today, and say, hey, take a look at what I'm doing. Okay, so they're gonna slide over the spacetop, give the glasses to another person, and they see it from the side, okay? They can't really see the content, okay? And what they do if they, God forbid, exit the room, they forget the screens in the room, okay? So that's a different kind of problem than you're used to. So how do we solve this? So the solution is to anchor your screen to the keyboard, which may sound trivial because that's what my laptop does, but it's a bit harder here. So let's see how that works. Okay, so again, same use case. I'm working on something, and I'm going to slide over, and you're going to see how the screens are anchored to your keyboard. Okay, and now you can see whatever the other person wants you to see, and if you rise and move, it moves with you. Okay? So let's see how we did this. Okay, so we have 2 inputs. First is the vision. So these are the glasses, the AR glasses that we have. We have 2 CD cameras running at 30 frames per second, and that's the blue start there. And then we go through a deep learning model which finds the bounding box of the spacetop in the field of view and some key points distributed across the keyboard. Then we run a PNP algorithm, and from there we have a 6DoF estimation. 6DoF is the X, Y, Z, and the 3 angles, pitch, yaw, and roll of the keyboard. So with 6DoF, we can understand where to draw those pixels. But that's not enough. We understood that we have to have also an IMU. There's an IMU located in the keyboard, which runs at 1,000 frames per second, and it provides a 3DoF estimation, the 3 angles, okay, pitch, yaw, and roll. And we synthesize both of them together, and together we have a very accurate 6DoF estimation per frame. And we don't settle for that because, of course, there's temporal information, so we incorporate that in the next step, the temporal information of the previous frames to get a better result. And finally, we have another level. We can understand what state you are in. Are you static, like on the disk? Are you carrying it on your side? Are you holding it up? Or are you even on an accelerating platform, which I'll talk about in a couple of moments. Okay, so this is an important input for the UX to give a different experience for each state you are in. So this is a bit Polish, but I'm allowed to because I'm Polish. My parents are. So what happens about low light environments? So this is in regular light. Okay, you can see the spacetop. There's lots of features you can find key points for. So this is easy. But what happens if you're in the dark? You're on a plane, it's at night, or you just like working in the dark in a room. Okay, so there's very little information here. And remember, this is not just saying there is a spaced-off in an image or plotting bound box in 2D. This is 6th-off. You have to be accurate to an order of a millimeter and an angle degree. Okay, so this is very tough problem. So we could have been on the oak. We could have let's collect a lot of data, train the most amazing models ever, or we could be a bit smarter. So we put an array of IR LEDs, which humans typically don't see. Okay, you shouldn't be able to see it, around here and not in the middle where people type. And then it shines up like a Christmas tree in the dark, and then the problem is much easier. Okay, so that's one example of methodology. What about UX? Can we do better than a physical laptop? So when the laptop is on your lap, so you're trying to balancing it. Okay, so if one leg is higher than the other, you have the roll angle. Nobody wants a roll angle. So the user feels guilty. So I have to shift so the roll angle will be okay. And what about the pitch? Nobody wants it to be flat in the other direction. You want it facing you. So can we do better than that? Since we have all these angles, we can cancel the roll and pitch. Okay, so this means that we balance the screens no matter how you put it on your lap. So there's no roll and pitch, so it's aligned to the ground and aligned to you. And there's only the yaw and the translation. Okay, so this provides a better experience than a laptop, actually. And now about accelerating platforms. Also, Vision Pro has seen some share of their problems with that. Okay, it's a common problem. And why is that? So in AR, you have to use inertial SLAM to provide really pixel stick and a good, smooth experience. And inertial SLAM, it means that you have to have an IMU, and the IMU can be confused when your platform accelerating. Okay? If you're on a plane, a train, a bus, subway, whatever, if you accelerate, then there are problems, and I'll give you a fun example. So this is taken on a bus, and let's see, the bus door will close, okay, and the bus will start accelerating, and bye-bye screens. Okay. And now it will decelerate, and bye-bye again. There we go. There we go. Bye-bye. Okay. So this is a common problem, and I'd like to share with you how we solve this, because this is unbearable. No user would be able to use our product with this. Okay, so let's say you're in this car and it's going to turn right. Okay, you're starting from position A, and your screen is here. Okay, so from the SLAM, it will because it assumes stationarity, so want to keep the screen there, and it'll be left behind, like you saw on the bus. It'll go behind us. Okay. So let's fix the translation. So let's go anchor the screens compared to the head pose. So take a few centimeters forward and a bit down, and that way you won't lose your screen. Okay, but that solves half the problem. Okay, it'll turn with you. But the angle will stay the same as in the same position, okay, the same angle. So, but we have a keyboard from the previous part, okay? So what we do is we set the 3D angle from the keyboard, okay? And then it'll turn with you. And this is how it looks, okay? Again, the bus. And it'll start moving, and it'll turn, and you see the screens are with you, and you can work even on the bus, which is challenging even with a regular laptop, okay? Trust me, I've tried that. Okay. So this is the solution, but there is an assumption here, which may be problematic, that we see the keyboard in the field of view, okay? And this is not always the case, as you saw here, okay? So what's the problem with that? So our users may be like the person on the bottom left, okay? They may look up, okay? They can, basically, if you want, we can let them look at the ceiling as well. There's no limit. But this is not, we could have worked hard in trying to do a model without the vision, but there is an easier UX solution, okay? What you can do is, well, ergonomically, this is not the right idea to allow the users to work like that, okay? They want their users to do this like a laptop, to work 8, 9 hours. So ergonomically, it's the right thing to do is to look down, okay, at a certain angle. And for us, it's for AP, accelerating platforms, it's a good idea because if you look down, we'll see the keyboard, okay? And again, you don't have to look down like you think you're looking at an object because we have a wide field of view in this direction. So you have to look just reasonably down, just like for the ergonomic. And this is what we've done. We've lowered the canvas so you can't look up like this person, okay, for their health and to work on these accelerating platforms. And this is a solution that worked for us. So I think I've demonstrated how, first of all, what is the space-top? And welcome to try it out. I have a space-top with me. So if you want, after the talks are over, approach me, you can try it out. I have exemplified how we work at Sightful, really trying to be nimble and being the reed and not the oak. And really, this is a product that provides a lot of value, and you're all welcome to enter our website and purchase it. And I'd like to thank my team, my amazing team, the algorithm team. We have a lot of fun, amazing people, and all the credit goes to them. And we have an open position as senior computer vision researcher, so you can scan the QR code or contact me on LinkedIn, and if you want to join us, please do so. Thank you.
What about the classes? Can I put the computer with my classes, or I need to just?
Yeah, I'll repeat your question. I'll repeat your questions, okay. The question was for a person who has seeing glasses, can they put them on our product? So we have clip-ons, magnetic clip-ons, which you attach. So we ask for a prescription before, and then you just use it without using 2 glasses at once.